Hello and good morning to everyone. We are from Group 7 will present about the MITEC Building as our case study. These are my group member Alia Shatra, Sarah Hazika, Muhammad Akmal, Anis Maisara and also Izri Nadira. This slide will cover about the table of content about the MITEC for the introduction, key features and building system, video performance analysis, discussion and also the conclusion. These are the video of MITEC from YouTube.
It began with a bold vision to build KL Metropolis, a development that would establish a new international trade and exhibition district in Malaysia, built in partnership with the government by NAZA Group's property arm, NAZA TTDI. The crown jewel of this grand vision is the Malaysia International Trade and Exhibition Centre, the preferred international destination for exhibitions and events. Like the fine gold and silver threads of the Songket weave that inspired its facade design, MITEC is the embodiment of refined craftsmanship, creativity and precision. As Malaysia's largest exhibition centre, MITEC's functional spaces are unprecedented. Primed for exceptional displays, surrounded by state-of-the-art facilities and amenities. This iconic structure affirms a commitment to innovative excellence. It is a showpiece of engineering ingenuity. An enduring icon built for a new Malaysian era of success.
For introduction, MITEC stands for Malaysia International Trade and Exhibition Centre. It's one of the largest buildings that earned the Green Building Index (GBI) certification. MITEC was built as for the largest trade and exhibition centre in Malaysia, and it also the third largest MICE, which stands for Meeting Intensive Conference and Exhibition Venue in Southeast Asia region. It is located at Jalan Duta Mas 2, Wilayah Persekutuan Kuala Lumpur, and the building orientation is northwest. This MITEC building is built by RSB Architect for the Ministry International Trade and Industry NAZA TTDI, and this building is spread across 13.1 acre plot near Duta Mas, and this building is opened in 2016, which cost RM 20 billion for the KL Metropolis development. We're moving on with the key features of the building system. We go on with one of the elements of the key features of the building is spatial planning. What is spatial planning? Spatial planning is help to set a recommended behavior within people in a certain space. As example, the ground floor in the MITEC buildings is set for drop-off at the front and also the loading bay at the side, and the main space is located at the middle. The planning have been operational and promote the people movement inside and also outside. This building is approximately floor area of the exhibition hall is 51,000 square meter, and the capacity of user for given moment is approximately 47,700 guests. This building have a very clear direction of dividing spaces, public spaces and private spaces, which is at level 1A and level 2A is a mezzanine floor for the office, which is have the void for the hall. For the level 2 and level 3 is for the exhibition hall. and every floor has their own ramp to be accessed to every floor.
Moving on to building form, this building derives from the unique mixing of the rubber seed, symbolizing the rubber industry's contribution to the economic growth of Malaysia. The director said that MITEC belongs to the government body and its main purpose is to ensure the independence of export business and services. Rubber that comes from rubber trees has been a fundamental source of income for a long time in our country, so that is the reason for the use of the concept as a point of reference and inspiration. He also said that the reference of the rubber seed is manifest in an abstract and contemporary manner. This Malaysian Trade Exhibition Centre, or MITEC, is using biomimetic architecture in developing the building. Biomimetic architecture is a multidisciplinary scientific approach to sustainable design that goes beyond using nature as inspiration for aesthetics and also applying the sustainable way to its building. More detailed, rubber seed has a sphere-oval form that geometries more to the bottle-shaped base. The bark is some shade of brown and black. Some of the buildings that have the same form as MITEC are Riverview Way, United States. Clad in curved steel and glass, this MITEC also is one of the types of high-performance building where it develops the energy efficiency to the maximum level. Uses of insulated roof, thermal performance curtain wall, horizontal sun shading device and skylights that allow controllable amount of sunlight with appropriate sun heat control. Going to the facade design, MITEC's facade is designed to resemble a shell, a fraction of the natural form of a rubber seed, which was very difficult to carve and construct. The meticulous detail of the pattern on the facade is derived from the weave of songket, a traditional Malaysian cloth that depicts the country's identity. MITEC's exclusivity was mirrored in this cutting-edge architecture, which aligned with their principles of redefining the event experience. The upward undulating lines of the front facade's sun shading system, as well as the curved lines of the metal screen features the main entrance glass canopy and the building's overall organic fluidity of architectural features, articulate nothing but the Malaysian trade industry's growth foreseen. The Sika Centerfield roof system was chosen because it provides perfect waterproofing under the decorative cladding system. The installation process is made convenient, reliable, and productive thanks to a unique anchoring device that is hot and welded to the membrane. Some of the characteristics that MITEC has for its facade design was the horizontal sun shading devices. This upward undulating line of the sun shading system is located in the front facade. The roof allows the building to reduce heat gain, resulting in a decreased cooling demand on the air conditioning system. The sun shading mechanisms let a lot of light in while controlling the sun's heat and preserving a good view of the outside.
We go on with the active system design, which has been applied in this building. This building is categorized as a smart building because of the maintaining the building performance. There are 11 categorized for winning practices, which are usage of recycled material during construction, installation of 70% repellent glass, sensor for the escalator, aircon and toilets, building automation system, and no chemical treatment, which is why this building is awarded as the Green Building certification. Next is the active system design, which is the mechanical ventilation system. The mechanical system help provide airflow through the building. This system allows indoor humid and stored air transferred and exchange with the fresh air from outside. This will help to maximize the thermal comfort in the building. As you can see, the colored legend in the floor plan shows the location of AHU room. AHU room is used to circulate the air for the ventilation and air conditioning system. Since this MITEC building is used to accommodate a large crowd, it is needed to have an AHU room for every floor. MITEC uses two different air conditioning systems, which are centralized system as the main system, while the control room uses a split air conditioning system. One of the interesting features about the MITEC is the usage of non-chemical water treatment that is collected from the rainwater harvesting system for its air conditioning and mechanical ventilation system. Next is the structural design. As we mentioned before, this building is an exhibition center. Therefore, it needs a large space to accommodate such a large crowd. The area of the column-free space on one level is 12,960 square meters. To achieve a pillarless design in the spaces, it used three main superstructures as shown as the picture below. This building is known as one of the largest pillarless designs in Malaysia. Therefore, it has become one of the significant landmarks in the city thanks to its pillarless interior and also the curved facade. Next is the use of low E class to reduce the amount of infrared and ultraviolet light without reducing the amount of daylighting entering into the building. As we mentioned before, this building used 70% repellent glass for the window, and that is one of the reasons why it is nominated as green building. Next is the insulated roof. This roof system is used as part of the facade too. This insulated roof helps to reduce heat gain and lessen the loads required for the air conditioning system. The left detail is the drawings is an example of the panel being placed and also the layers needed for the building protection. This system changed the perspective of conventional roof design in Malaysia.
Moving on to mechanical transportation system, there are two types of escalator models that were installed in MITEC, supplied and manufactured by Cone Elevator Company, namely the Travel Master 110 and Transit Master 140. For the type of elevator, in MITEC, lifts can be located in 10 different places, totaling 17 lifts, despite the fact that the system has only 3 main superstructure tiers, 3 additional mezzanine floors for each level and 2 basement levels. For the passengers lift, there are two different models of passenger lift in MITEC. The first type is the commonly seen lift that is embedded into the walls of the building, whereas the second type is a see-through glass lift that is also considered the centerpiece of the building. The other type of elevator is a freight lift. MITEC has a total of 2 heavy-duty freight lifts, both of which are located at the back end of the building behind Hall 1 and Hall 4 respectively. Since it is closer to the kitchen area, the freight lift behind Hall 1 is smaller in size and is mostly used by kitchen staff to move food and kitchen products. The freight lift behind Hall 4 is, on the other hand, larger since it is mostly used to carry products to exhibition halls, which necessitates a freight lift of greater loading capability. Going to the other type of elevator, the gearless traction lift is recognized by its wheel that is attached directly to the lift motor instead of being attached to the gearbox as in case of gear traction lifts. This type of lift requires a machine room and is typically placed directly above the lift shaft to minimize the length of rope and optimize its efficiency. This type of hoist mechanism is used for the standard passengers lifts in MITEC. Moving on to another type of elevator, this type of lift lobbies is a pressurized system in the elevator lobby to ensure that it is smoke-free and sustaining air circulation in the case of a fire in which firefighters must enter the elevator lobby for rescue or firefighting. A pressurization ductwork is located within the protected pressurization shaft in the elevator lobbies on each floor of the MITEC. Fire dampers are not usable in lift lobbies. As a result, the pressurization ductwork is employed to maintain a positive pressure in the lift lobbies in order to prevent smoke from entering while also providing vented air.
Alia here, so moving on to the building performance analysis with regulation view BBL bylaws 1984. Natural and mechanical ventilation system that they provided in MITEC building is that they have this louvered heat ventilator for the natural ventilation system. It indicated in the level 1 floor plan here and the section in figure 31 having this sort of airflow diagram through the louvered openings. The mechanical ventilation system, they have this induced jet fan and ductwork in basement car park, and of course fan rooms indicated in the basement 1A and 1 floor plans respectively. Referring to the third schedule, we need to have like a minimum of 6 air changes per hour for the mechanical ventilation system in basement areas and are not less than 0.5 meter above the floor level period system and a minimum of 0.28 centimeter per person working in such area. They use exhaust ventilation, and this operation is used in car park basement. It performs by depressurizing the building, which is exhausting air from the structure, causing change in pressure and pulls in makeup from outside through leaks and building shells. Referred to BL249, smoke and heat venting. This is to provide for the safe use of exit. So in order to vent the smoke inside the basement area, we need the system. And referred to BL251, it is needed smoke vents, so to prevent dangerous accumulation of smoke. In air conditioning system, the building shall have a minimum of 10 air changes per hour at a rate of 0.61 centimeter per square meter of floor area, a minimum of 2 chillers, and a thermostat for regulation of temperature. Now they have these in MITEC, the cooling tower, the water tank, and the chillers being located. The right picture shows a combined use of ductwork for conventional and free cooling, and one of these is in the halls in MITEC. MITEC actually utilizes a DCS, which is district cooling system. It distributes chill water from a cooling plant, just like shown in figure 39 here, to various building blocks through pre-insulated pipes and seamless underground pipes. Like in the figure here, it distributes through the pipes and then to AHU and then the active chilled beams. And so many buildings demand cooling energy, which DC actually offers. So it uses electricity, natural gas, water, and even seawater to power it. It increases energy efficiency, and it also reduces environmental emissions. For the active and passive fire protection system, the emphasis on using water cannon system. Here is the indication in the plan, and that is the fire artillery. So the section shows the water cannon system indicated in the pillarless building. So system operates when fire happens and the temperature increases. Therefore, a smart scan will be performed in horizontally and vertically directions to locate the fire. Then it pumps the water valves, it sends the signal to the central control, and a warning. So the fire artillery will extinguish the fire. This refers to, again, BL231 and 248. Yes, the building is 63 meters, so that's why we need a wet rising, and of course it's red painted on the wet riser and etc. The passive system here we grouped in two, which is compartmentation and exit consideration. In fifth schedule, referred to BL134, it is a place of assembly. And the compartmentation here is the basic components that they use: fire-rated walls and doors, fire-resisting, efficient smoke seal, false ceiling, and protected route. Refer to BL137 and 136 here. The floor in building exceeds 30 meters in height. That's why it's to be constructed as compartment floor. The plan here shows the indication of the compartmentation of fire escape. The passive system for the BL140, which is the fire appliances, having to exceed 7,000 cubic meters, which is like then concludes that it is a island site, so they need to have like not less than 12 meter width and accessible to fire brigade appliances, and as well as having the access way minimum 6 meter. The floor needs to be 30 tons load accessible, and so that the fire brigade easily accessed. The exit consideration part refer to BL106 and 1062, having the fire doors of the appropriate FRP specified in the 9th schedule. Now, the purpose group that we have here is the office and place of assembly for the limit when alternative exits are available. This is referred to the 7th schedule of UBBL. Now, the right figure here is shown is the evacuation route for the general direction. The horizontal and the vertical exit routes indicated in the blue and orange color. These are the fire requirements that they referred for the building by law, and these are the fire alarms and fire detection, fire extinguishment, and firefighting access that they refer for the BL. As such, here I've actually categorize the active and the passive system. And then what we can actually discuss from here is that for air conditioning systems in MITEC, it is well maintained, as it is a very modern building. The machine does not really cause any sound pollution, as it's really strategically placed away from the public spaces. It's doing great for the soundproofing system, and therefore to avoid sound disturbances, like for example, they have wall paddings. And then for backup purposes, they have this something like that stores the electricity in case of any current break happens. The mechanical ventilation system, as I've already explained, they use exhaust ventilation, so it extracts out excessive heat and humidity out of the space while achieving thermal comfort. And for the mechanical transportation, it is becoming a vital part. It is a new large-scale building, so it's very convenient, and accessibility is provided for the mechanical transportation, lifts, escalators, and it also like accessible for the everyone, like any user. So it has streamlined our human processes within buildings and spaces. In conclusion, MITEC has implemented new technology like the pillarless structure design and planning, water cannon system for active fire prevention, and green technologies. Therefore, it becomes more environmentally sustainable and efficient. Other than that, it complies with the UBBL standards in terms of ensuring building protection for high occupancy users. And therefore, the MITEC building is a smart building. It becomes like a fresh approach to aesthetics, functionality, technology, and safety. So thank you for listening and watching our presentation here. We have learned a lot on the building services and how the building performs.